Alright, so in this pencast I want to show you, in this screencast I want to show you how to use Vpython. Alright, I'm going to take my velocity time graph and figure out what my acceleration is first. So if I take the slope of my acceleration graph, it looks like it's about -7 centimeters per second every second, which means that each second my fan cart, while moving in the positive direction, slowed down by about 7 centimeters per second. And then at 0 seconds, it looks like it had a speed of about 15 centimeters per second. So if I want to write the equation for this line right here, it's just going to be v equals my acceleration times time plus my initial velocity, right? And the equation for this curve here is a little more complicated. To do that, I would do analyze model, and I would choose quadratic right here, and I'm going to move this over a little bit so you can see what we're looking at. Whoops, quadratic's up here. And let's see, my acceleration was -6.998. I want to cut that in half. So what was it again? 6.998. 6.998 divided by 2. 3.499. Okay. So for my A term, I'm going to write negative 3 point, let's see what that was again, 499, okay, -3.499, okay, so that should be half of my acceleration for my A term. My B term is going to be my initial velocity, which is 15.32 times t, so write 15.32 times t, and my initial position was very close to 0, so that looks really good. Wow. So because I made my coordinate axis, I made my object start at 0 centimeters at 0 seconds. I put 0 right where I was starting with my video analysis. It looks like it came out really good because this curve matches my data really well. Okay, so I'm going to use these basic equations in Vpython. Notice position is going to be 1/2 acceleration times time squared, plus initial velocity times time plus my initial position, and my velocity is going to be my acceleration times time plus my initial velocity. Okay, so I'm going to open Vpython, open Vpython. For my computer, I open Vpython, which is should be running now. Alright, there it is. And I'm just going to open, I like David Weaver's version, so I should be able to find David Weaver's version here. I put this up for you guys online, so this is all on the website. I think it'll be down here, right? Yeah, I'm going to open up this one. Say open. Alright, and the first thing I'll do is save it, file save as, and I'm going to save it to the desktop, and I'll say I'll just call this fan cart, and I'll save it to my desktop, and I'll say Mr. Day. Again, I talked to David Weaver, he's a friend of mine, and he said I could modify this stuff any way I want. Constant acceleration fan cart. Okay. And then I'm going to press Apple S to save my work. Okay, and now I'm not going to change anything here. I think I should change the ball. It must have been a program where I made a ball, so I'm going to just call it a car. And I'll make my car a box, and that's where I'll have my box start. That's where my car will start. This is horizontal, X. This is up and down, Y. And this must be the Z plane. That's why there's 3 numbers here. This is X, Y, and Z. And then this gives the length, width, and height of the car. And this isn't a red sphere anymore. This is a, looks like a red box. So I'll change this to red box. And the ground is fine as it is. I'll save my work, and let's just see what we have right now. So I'll run it, F5, and it looks like there's no issues yet, except I may not be running. Oh, it looks like it's okay. Yeah, it looks like it's fine. Just checking. Nope, it's not okay. So it looks like I have issues. And the reason I have issues is because I changed this to car, and everything else that depended on ball is all, there's code here that depended on the position of the ball to be defined. So I better fix everything first. So car, I made it crash. So this is the car's initial horizontal velocity, and I need to give it a horizontal velocity because my car was moving to the right 15 centimeters per second at 0 seconds, so I'll just put 15 in there, right? And my acceleration, it looks like it was, if I go back here, it was -7. So maybe I'll try, let's see here, I'll put -3, see if that works. And these are X in the X direction, and I got to change this to car dot acceleration, and then I'll change this to car trail. And this is a moving car, not a moving ball. And I better change that to ball. Instead of ball.color, it needs to be car.color. And I'll save my work. And it looks like I've made my initial acceleration -3. And actually, I think I want -7, right? Whoops. So I'll fix that again, -7. And I better change the code here to car's velocity. This is actually the physics right here. You should recognize this equation as the equation from the last pencast. So I'm going to need to change it to car. And basically this is the initial velocity of the car times the acceleration of the car, and the dt is just a small increment of time. So this is v equals initial velocity plus at. That's what this is. That's the only thing I have to modify. And this equation here should say car, again, car dot position plus car velocity dt, and actually I need to divide by 2 here, right? Because this should be divided by 2. Okay, and then here I need to have car trail, and then here it's car position. Okay, so the two physics equations here, that's really all the physics right there. And I need to change my initial velocity and my initial acceleration, and let's see what I have. Let's see if it's close. Oh, there's an error. Okay. Let's see where the error is. Okay. Not sure what happened there, but hopefully that fixes it. Okay, no, it doesn't. Let me try that again. Save my work. Okay. So I'm not sure what's wrong. Oh, there it is. There's my issue. Alright. So let me move this. Okay. Okay, should be getting better. Nope. Alright, so I'm not sure what was wrong, but I think I fixed the code. I changed a few numbers, so I should probably show you. Now I should also, this creates a red box, and I'll save it. So the position of my car in the beginning is a negative number. Okay. And my initial velocity right here is a positive number. I'm only really changing these numbers here, which are my x values. So the position horizontally x direction. My velocity at 0 seconds is this one. And I'm establishing my initial velocity to be 10. The part after the number doesn't change the code, but I'm documenting it as I go. And then the car's acceleration, I'm just making negative 0.5. It doesn't have to be exactly the same acceleration as my car. I'm just kind of playing with the acceleration to make it so that it behaves like my fan cart behaved. And let's just see if it works. I have my equation v equals initial velocity plus at right here. And the computer is just doing this over and over and over every thousandth of a second for 35 seconds. So it's doing 1,000 calculations times 35. So it's doing 35,000 calculations to do this simulation for me. Let's see how, hopefully it works out. All right, there we go. Car slows down, and then the car speeds up in the negative direction, and that looks pretty good. Cool. So again, I'm going to put this file up on the website. So if you'll scroll down, you'll see this file uploaded, and you'll have to open it with Python, and you can play around with it till you get it to work. Right here, this is the physics right here, and this part here, and this part here. This is basically position equals initial position plus initial velocity, no, final velocity times time over 2, and which is the same thing as 1/2 at squared plus v naught t plus x naught. So those are our two equations. Hope that helps, and have a good night. Thanks for watching. Again, this file is uploaded for you to play around with. Have a good night.